This is joint work with Imana from Princeton and John Heidemann from USC. So I'm talking about ad delivery. What is ad delivery? Ad delivery is the machine learning and algorithmic process by which ad platforms decide which users are going to see which ads. And particularly for domains of economic opportunities, such as employment, housing, education, this algorithmic process has become the gatekeeper to access to these opportunities. And there's been several black box audits that have shown that this ad delivery process is discriminatory. And that's, the black box audits is what keeps the companies really accountable and has resulted in settlement to change the process. How does the state-of-the-art black box auditing process work? Well, it runs a pair of ads targeting the same audience at the same time, and then it looks at whether the ads are delivered differently relative to each other by demographic group. So taking an example from an audit studying discrimination in education ad delivery from FACT 2024, the idea there was to target an ad at an audience that is 50% white and 50% black, and to run two ads, one for a for-profit university, another to a public university, and to observe that the delivery for the for-profit university is 60% black, whereas the delivery for public university is 40% black, from which one can conclude that it's the ad delivery algorithm rather than other confounding factors that influence that the for-profit university ads are disproportionately steered to black users. When it's run with this 50% white, 50% black audience, how is that done? How is that audience created? Well, that's actually pretty challenging because access to demographic attributes is hard to obtain. The workarounds typically used are using publicly available voter data sets that have these attributes, asking volunteers to self-identify, or trying to infer these attributes from other available information. And so in this paper, we focus on efforts that infer these attributes from other available information. You would not be surprised to hear that when one uses inference, these inferred demographic attributes are pretty noisy. For example, for race inference, the state-of-the-art method called BISG dates back to 2009, but it just relies on name and location, which of course is not enough to accurately infer race. And it has been shown in other contexts that when one relies on inferred attributes with error, it can lead to incorrect estimation of disparities. And our goal in this paper is to see how does reliance on inferred attributes with inference error affect the accuracy of black box ad delivery audits. Our contributions is first to show that if one just relies on inferred attributes without doing anything, these black box audits can lead to underestimation of skew in delivery. And our second contribution is to propose a correction to the statistical inference method that can expand the range of detectable skew. Let me spend like 1 minute on the technical setup so that all the assumptions for the technical contributions are clear. We assume that algorithmic skew operates on true attributes rather than the noisy inferred attributes. And we assume that there's some base delivery rate R, so every user gets a probability of seeing this particular ad with rate R. But if the delivery is skewed, then there's a skew parameter that decreases or increases the probability of seeing an ad for users from a particular group. We also assume that this inference error can be characterized by a false discovery rate for each group, where the false discovery rate is the percent of users in a particular group that are inferred as belonging to that group, but are actually not in that group. So what's the problem again? What's the intuition? The intuition is this is how the whole process works, right? The auditor uploads a targeted audience, then the advertiser runs this pair of ads, and then what the advertising platform reports to the auditor is just the aggregate number of impressions per ad. And so the auditor has no way to run the inference again on what are the races. It has to operate on these aggregate information. And if one relies on aggregate information where there's inference error, it's pretty obvious that this is not going to be a correct conclusion, right? So imagine this is my delivery audience where half of the delivery audience was inferred as belonging to group A and half was inferred as belonging to group B. If I just use these numbers to look at the delivery rate, then I conclude that 50% of the delivery audience is belonging to group A and 50% belongs to group B. But if I actually look at the demographic breakdown using true attributes, the picture is completely different, and the delivery is 31% to group A and 69% to group B. And this is the intuition for why, if one does not correct for the inference error, one can simply reach erroneous conclusions. So our first theorem, just stating here informally, is that ignoring inference error underestimates a skew. And the intuition for that is that the inference error really dilutes the audience composition, reducing the ability to infer the effect of the algorithmic skew by true attributes. And our second contribution is the inference-aware skew evaluation, again stating here very informally, assuming that we know the FDRs of the attribute inference method that we're using, we can then kind of estimate how the error propagates through the whole pipeline of testing and adjust the ad delivery statistics and the statistical tests to correct for that. And just to visualize this, without going into the details, what our method does is it expands the range of skew for which the skew can be detected. So if without our correction, one could only detect the skew that was very, very large, with our error correction, the skew detection is larger. In conclusion, we think that attribute inference is a promising tool for expanding scope of black box delivery audits. However, one has to account for inference error when doing so. And in cases when the false discovery rate can be estimated, we think auditors can leverage our method to expand the range of discriminatory skew that can be detected. Thank you very much, and happy to take questions.